CNT120, we're working on Chapter 4. Now we're working on ARP, Address Resolution Protocol. Again, another network layer protocol here. Okay, layer 3, network layer protocol. The function of ARP, this is really an IP version 4 thing. Its function there is to use broadcasting to find out a MAC address for a known IP. So if I think it through, if I think back to Chapter 3, I can find an IP address by using DNS. So I can hit my DNS server and learn an IP address, but then I need to know a MAC address to be able to put that in my header. So ARP often gets used to find out, okay, when I know an IP, learn a MAC address. And that MAC address, theoretically, is the MAC address of who I'm trying to talk to, but it might actually be the MAC address of my gateway, wink, wink, that's going to get me to the device I'm trying to talk to. That happens. A lot of times when I ARP out, the gateway is going to be like, here's the MAC address that'll get you there. I don't know any different, but my machine at least has an entry in its table for a way to get to that device. Okay, so it really is a protocol to get the MAC address when I know the IP. Here's a sample ARP table. Every machine is going to maintain this. As it learns them, it maintains them in its table. I can actually see that by using an ARP command, ARP-A kind of command, if you will. I can actually look at my ARP table. Here's a sample ARP table from a Windows machine. We'll look at ours here in just a minute. So let's take a look at the ARP protocol, then we'll look at our ARP table. So I'm going to, again, I'm going to start my Wireshark here. I'm going to let it run for a little bit. I'm connected out to the just the college network. I'll let it run for just a couple minutes. I might even prompt it along by loading a web page. Let me load a IMSA web page here just to prompt it along a little bit, make sure it's capturing some stuff. All right, good deal. Now we have a couple thousand packets to look at. So if I come in here now, and I'm going to start with just a plain old TCP packet. I don't really care what it is. If I remember with my TCP packet, here's my TCP, here's my IP, here's my Ethernet. If I look at this, I see actually a source IP of, or excuse me, Cisco Ethernet address is a source. The destination address is a Dell. These are actual MAC addresses of things. If I look at the IP header, I actually see a source IP and a destination IP. Okay, that's an ordinary data packet that I would see on a network. If I now look at an ARP packet, here's an ARP. I'm just going to pull one of these open. Here's one from a Cisco. I'll do this guy right here. If I open this guy, here's my Ethernet header. Here's my ARP header. Okay, ARP is, here's my ARP header. If I remember what ARP is doing, okay, it's trying to learn the MAC when it knows the IP. So if I keep that in mind as I'm looking at this, let me go back here now. The source MAC address is a specific MAC address of a device. But the destination is a broadcast because I don't know the MAC address. I'm going to broadcast it out hoping somebody responds to me. If I look at the Ethernet or the ARP header now, I see that the sender IP address, here's the sender's IP, 172.23, it's a specific node. Here's the sender's MAC address, that's a specific MAC address of a device. The target IP I know from like DNS, 172.23, that's a target IP, but I don't know the destination MAC address, so it fills in all zeros. And again, coming back to the Ethernet header, it's going to broadcast it out. It's saying broadcast, somebody tell me this, and it's leaving this like a blank. So hopefully it gets filled in. Hopefully somebody responds to me, and I learn that and put it in my table. That's the function of ARP. That's the function of ARP, to try to get the MAC address when you know the IP. And if I look at it, you know, if I keep that in mind and I look at my Ethernet header and my ARP header, it starts making sense. Okay. Well, after I have done that, if I actually on a computer look at the ARP table, oops, excuse me, ARP-A. If I look at the ARP table, here's my command ARP-A. Here are entries of IP and MAC that it has learned, IP and MAC that it has learned. These are all dynamic, so they're going to go away once this machine shuts down or reboots, but these are probably all IP addresses of all the lab machines in this room, as well as the MAC addresses. I'm going to bet they are because I see a lot of 1866. That's all the Dells in this room. So here is all the IP and MAC address mappings that it has learned throughout the day. And it keeps them in a table. That way it hopefully does not have to ask this again, broadcast this out again, saying, hey, does anybody know this MAC address? Okay, that's the function of ARP, to build this so I have the IP and MAC address mapping that when I go to send a packet, let me close this out. As I go to send a packet, come down here to one of these, I have all the information I need to fill in source and destination MAC, and then eventually source and destination IP. That's the function of your ARP. Now, I also have this on things like my Linux machine too. So let me pull this guy up and I'll do an ARP over here. Well, he's going to be a lot smaller because he's on a virtual machine, but I still do have IP address to MAC address mapping. I do. Any device is going to maintain this table of information so it does not have to keep asking for it. Almost like a little address book or a little date book kind of thing. So there is ARP and ARP on networks.